All right, so now in this lesson, we're going to talk about regression. And I gave out these instructions on how to plot data using the calculator. And then the regression, basically what it means is like, okay, we had an equation. The equation gave us a table. What if we actually only had a table and we wanted to come up with what the equation was? So this is really cool because in real life, if you become like a mathematician or a scientist or something, and you're collecting a bunch of data, and then you want to say, well, does it fit into can I make an equation that could fit the data? And it's not going to fit exactly. It's what we call like an equation of best fit, okay? And it gets pretty close. So I'm going to give this example from the activity number 3. Each table shows a relationship between speed, miles per hour, and gasoline consumption, miles per gallon. In each case, use a quadratic regression. So that's why I know I have to get out these instructions. Use a quadratic regression to find the quadratic function that would best fit the data and answer the following questions. So this is kind of cool because it does it all for you. So as soon as you see this, you're like, find the quadratic function. Well, how would you do that? You would use the instructions here. So we're going to start with our calculator, turning it on. And these are literally like, one time I used to work in a credit union and I had to open people's accounts. So I needed a procedure for that. I had to go to my procedure manual. This is basically, the regression is like a procedure manual. So the very first thing we're going to do is we're going to press stat. Okay. And then we want to push enter for the edit, and we want to clear out any of our old data. So if I go up to list 1 and I press clear and enter, it clears everything out. That's from the instructions, okay? I go over to list 2, I press clear and enter, and it clears out all the data. So when we make a list 1 and a list 2, we're essentially making an XY, we're making a table of values is what we're doing. So list 1 is going to be our X's. So now we're going to enter the data. To enter the data, I'm going to go back to my table, and I'm just going to literally plug them in. 5, I'm doing the top one. This is my list 1, and this is my list 2. Okay, so 5, enter. 15, enter. 20, enter. 25, enter. 30, enter. 50, 60, 70, and 75. Okay? Then I'm going to go over to list 2 and I'm going to punch in those numbers. So 5.1, these are my Y values. 11.4, enter. 12.5, enter. 15.6, enter. 19.0, 27.3, 28.2, 22.9. Oops, I didn't get that one right, did I? 22.9. And again, 22.9. There we go. And 21.6. Did I do it right? Okay, you're my eyes and ears now, okay? So that's my table of values. Again, these are my X coordinates and my Y coordinates. Can you kind of see any kind of pattern to the numbers? Yeah, they're kind of going up, and then what happens is it reaches a maximum and it starts to go back down. So that can kind of imply that there's maybe a vertex around that maximum point, okay? So now, next step, if we want to plot it on the scatter plot, we'll go to y equals, and to create a scatter plot, we're going to go second y equals, and you see how it says stat plot, right? So we're going to press enter on that, and then there's lots of different style options, but they're using X and Y as list 1 and list 2. So let's push enter, oops, plot on. Now what do I do? Go back to the instructions. Okay, then we'll just go to y equals, and let's press graph. And actually my graph is kind of all messed up because I'm still graphing the old parabola. So instead, let's do this. Okay, I'm going to go back to y equals. Let's clear out. We only want to graph the plot. Now notice some of you have a hard time graphing because your plot is turned on. In this case, we actually want the plot turned on. So to create a scatter plot, okay, we did all that. Now I want to do zoom stat. So if I go to zoom, and then you see where it says zoom stat, the 9th one, you can scroll down or press 9, and press enter. Okay, so now what it's done is it's plotted all of my scatter plot. This is my scatter plot, and you can kind of see it has a little bit of a parabola shape to it, okay? To improve the view, you could press window, but we don't really need to improve the view. I think we have a good view there. Okay. Now we're going to perform the regression. This is the part where it's actually going to give us the formula, the equation. Okay, so we're going to, how do we do this? We press stat. Where do you see your stat button? Now I lost my stat button. Oh, there it is. Okay, press stat, and then we're going to go over to calculate. Now it has all of these different kinds of regression. Linear regression would give me an equation of a line. Quad regression, does that sound right? Quadratic? Ah, okay, we want a quadratic regression. List 1, list 2, and we push enter on that. So we're back on the back side now. I'm kind of skimming over these instructions, but you can read them over later at your leisure, okay? Where am I? I think calculate. Done. Okay, there's probably some other fancy instructions here, but essentially I'm getting the equation right here. So it's giving me the A that goes in for the A, the B that goes in for the B, and the C that goes in for the C. So if I want to write that equation, where should I write it? Okay, and it wants it accurate to 3 decimal places. So we have y equals negative 0.008 x squared. Does everybody see where I'm getting that? Plus, tell me what to write next. 7x, good, because that's my b. And then minus 1.307 to 3 decimal places. Now there was a fancy way, if I look in here, but I don't want to do this right now while you guys are waiting for me, but essentially there's a fancy way if you follow these instructions on how it will actually input that formula into your y equals. But if you go back to y equals and you type it in, negative 0.008 x squared plus 0.957x minus 1.307, right? And if I press graph, look at how cool that is. Do you see what's happening? It's like connect the dots. It doesn't fit exactly, but it's pretty close. So what I did was I just took the equation that I got from doing the regression and I graphed it over the top of the scatter plots. And in fact, that's what this instructions, I haven't done it in a while, so that's why I didn't want to read it in front of you. But essentially, that's exactly what's happening here is it's going to draw that parabola and you see how it kind of goes through the data, right? From that, use the quadratic function from part A to estimate the speed in miles per hour of the Oldsmobile. The Oldsmobile should be driven to give the best gas mileage. Round your answer to 1 decimal place and include units. So if we want the best gas mileage, what is that kind of referring to when it comes to this equation? Yeah, so it's basically the maximum. We're talking about the vertex, aren't we? So we want to use the function to find the vertex. So essentially we want to find the vertex where we're going to get the maximum miles per gallon. And so we're going to use x equals negative b over 2a, but also those numbers are really not super friendly. So do you remember how we could use the calculator to find the vertex? Can I just use my pointer and scroll up there? Or is there a way that I can find the vertex using the graphing calculator? Yes, second calculator. Which one would give me the vertex or the maximum? Maximum, good. So we go here. Am I on the left-hand side of the maximum? Yes. Scroll past the maximum to the right-hand side. Am I on the right-hand side of it? Yes, enter. And now guess, press enter again. Our maximum is 59.8. This is our vertex, 27.3. So that's our vertex. Use the quadratic function from part A to estimate the speed in miles per hour. So what part of this is the speed? Yes, at 59.8 miles per hour, what do I get? I get 27.3 miles per gallon. You're right. So that is from the, yes, okay, that's exactly right. So this is the best one. That's real life. But they wanted to know according to the function. Because remember that the function is not a perfect fit of the data. So according to the function, this is the answer. But according to the graph, that's the answer. That's a little bit confusing, right? But the main thing is that they're asking us using the function from part A, you know, and you could do all that math by taking the A, B, and C. So the regression is not a perfect fit, but it's a pretty close fit, is the idea. Okay.